Hello geometers, this is Miss Backfish and I am here today with you to talk about finding the area and perimeter of polygons in the coordinate plane. Okay, what do I mean by that? What is the coordinate plane? Basically on a graph, polygons like these. And these are the ones we are going to look at in just a few minutes. First, let's talk about what do I need to know in order to do this. Well, the basics, the very basics, is I need to know what area and perimeter are. Okay. Usually we talk about perimeter first, meaning perimeter is basically the distance around something, and I'm being very generic in my definition here, and area, or very casual I guess you could say, area is the space within, the space inside of a figure. Alright, so polygons, it's helpful to know what those are too. Those are basically, we're talking about not circles, any kind of shape that can be made up of segments that don't cross each other. Squares, hexagons, triangles, pentagons, etc. Now, we're not going to do some of those that I mentioned. We're not going to do hexagons, pentagons, etc. We're going to do basically quadrilaterals and triangles, three-sided and four-sided figures. And it's worth mentioning that if you were to try to do a pentagon, for instance, or a hexagon or anything else, it could be done by splitting it up into two figures. One's a quadrilateral and one's a triangle. So anytime you get to some of these bigger polygons, consider dividing them up into smaller polygons that you already know how to do. Alright, so if I want to know the distance around something, let's just say it's a random shape, then basically I need to know the side lengths. So I need to know this length, etc., and I need to add them all up. Okay, so I need to know how to find the length of a segment. So that's distance formula. So I need to know the distance formula. The distance formula, which also actually works just like the Pythagorean theorem, and you can do it with Pythagorean theorem, is looking at finding the difference between the x's, or the horizontal distance, and squaring it, and then finding the difference between the y's, which is the vertical distance, and squaring it, adding those together, and then taking the square root of the whole thing. Another thing we need to know in order to do this, and really in order to do anything with coordinate geometry, is how to find our slope. Okay, find the slope of a segment. So let's look at the slope formula. We usually use the letter M to stand for slope. It's the change between the y values, which is the vertical change, also known as the rise, how much does it go up and down, over the change between your x values, or the horizontal change, left and right, which is your run. Okay, so the rise is up and down, the run is left and right. Okay, for the purpose of slope, it's important to realize that going up is positive, going down is negative. In other words, if you're going down, you say, I'm going down. -3 means I'm going down 3. Left is negative, right is positive. So let's use those. Notice that we use, these look similar, and that basically this, when we say x sub 2 minus x sub 1, that's just saying the horizontal distance. So here we're looking at the vertical distance over the horizontal distance. Here we're using those and squaring them and adding them, etc. Alright, so let's dive right in to, actually, one more thing, sorry. One more thing we need to talk about is how do I find the area of various shapes? Okay, and we can do this as we go, but let's just talk about some of the basics. If we want to find the area of a rectangle, alright, then we say I'm going to multiply the length times the width, which means I need to know the length and I need to know the width, which is where my distance formula comes in. A square counts as a rectangle. It's just that the length and the width are the same. So for a square, that would be s squared, is how we usually write it, side squared. But you can still think of it as length times width. Triangle. Triangle, the area is 1/2 the base times the height. Now, what makes the base and the height? Well, basically, you have one of those is a side of the triangle, and the other one is perpendicular to that. It's an altitude. It's perpendicular to that. and we're going to look at that more in a second. Let's talk about a parallelogram. Parallelogram is just base times height. And finally, the last of the ones we're going to look at today, trapezoid. Trapezoid is like you have a triangle, but you have two bases. You don't just have one base. So instead of 1/2 base times height, it's 1/2 the sum of my two separate bases times the height. Okay, so here we have several polygons that I have drawn, 5 of them, on the coordinate plane so that we can practice and look at different scenarios, different ways that this might occur in nature, so to speak, or in a math textbook. So first off, we have a triangle here. Now, triangle area formula, remember, is base times height, 1/2 base times height. So I need to know a base and a height. Well, I'm going to go with, this is the base, and then this would be the height. Now, when we can do it like this, where we can draw an altitude, and technically what an altitude is, the definition of an altitude, it's a segment that goes from one of the corners, one of the vertices of a triangle, to the opposite side in such a way that it makes a right angle. So it has to make a right angle. Now, sometimes that's harder to see. Here, because this particular side is horizontal, I don't have to do much in terms of proving to myself that this would make a right angle because it's vertical. So when I can use the grid lines like this, if one of the sides of the triangle, it could be any side of the triangle, is on a grid line so that it's either horizontal or vertical, then I can just find a segment, an altitude that is the opposite. In other words, for this one's horizontal, so I need a vertical altitude that goes to it, and I can say, yeah, that's going to be a height for this particular segment. That works. This works as the base, and this as the height. Now, the other advantage of vertical and horizontal segments is I really don't have to do the distance formula because I can just count. All right? The difference between the x's here is going to be my total distance because there is no difference between the y's. So I can just say the length of this segment is 1, 2, 3, 4, 5, 6. Remember that when you are looking at distance, you are counting the spaces, not the marks. Now, another way to look at this point over here is at -3, -1, and this point right here is at +3, -1. All right, notice there's no difference between the y values, so there'd be no point in taking the difference between the y values. Remember, that's one of the things we do in the distance formula. We don't need that because there's no difference. So we're focused on just this. I can look at these two numbers, and I can figure out how far apart they are. Now, depending on which direction you subtract, if I do 3 minus a -3, I get 6. If I do -3 minus 3, I get -6. But remember that distance is never negative. Okay, so if you do it one way or the other, the only difference would be the sign, and we have to remember that distance is always positive. So the difference here is 6. So the distance for that base is going to be 6. That's the base length, or the length of the base. And here we have the height as 1, 2, 3, 4. So my height is 4. So area is 1/2 base times height. So 1/2, 6 times 4, and that is 12. So 12 square units is my area. All right, so I found the area first, and we don't really have units here, so I'm just going to say 12. Your teacher might ask you to say units squared, but I'm not going to worry about that too much, or u squared. Remember not to accidentally write it like this. Think, oh, I have to have square units, so I'll put this. That's not the same thing as saying my units are squared. Saying my units are squared is literally saying that I have 12 squares. 1, 2, 3, and so on. Okay? We're talking about literally 12 squares. We're not talking about 12, the number, squared. That would be 144, which would be a totally different answer. So it's the units that are squared, not the number. Next, perimeter. Now that's going to be a little bit trickier on this one because I can't just rely on that whole horizontal and vertical thing where they're easier to count. This is not a horizontal or a vertical line. Neither is this. For this, I'm going to go ahead and I'm going to label the vertices of my triangle, I'm going to go ahead and say A, B, C. Perimeter is the distance all the way around. So I need to add the length of AB plus the length of BC plus the length of AC. Well, AC is easy. We already know it's 6. Okay? Now I've got to find the length of AB. Over to the side here, let me go ahead and write my coordinates. A is at, we said, -3, -1. Where is B? B is at 1, 3. And C is at 3, -1. Okay, so I'm going to use the distance formula for AB with points A and B. It really doesn't matter which one you consider x1 or y, x1 and y1, or x2 and y2. Sorry for that little mark. It doesn't matter which one you consider point 1 or 2. As long as you're consistent in the direction in which you subtract, basically. That's actually what I'm saying right now is true for slope. Okay, for slope I need to be consistent. Honestly, for distance formula, it doesn't matter at all. Because if I subtract one way versus the other way, the only difference would be the sign, and look what you're about to do. You're about to square it. So that's going to take care of that difference. If I square -3, I get 9. If I square +3, I get 9. So if you take the opposite of a number and square it, you're still going to get the same thing. So I'm going to take the difference between the x values here. Here are my x values. -3 minus 1. Plus the difference between the y values. Here are my y values. -1 minus 3. And I'm going to square those and add them. So that's -4 squared plus, and this is also -4 squared. If you had done it a different way, you would get +4, but look what's going to happen. When I square that, I get 16. Either way, I would have gotten 16. So we would be good. Your teacher may want you to go ahead and write this in simplified radical form, simplest radical form, which would be 4√2. Okay, next we have segment BC. BC is difference between the x's, so 1 minus 3 squared, plus difference between the y's, 3 minus a -1 squared, so 1 minus 3 squared is -2 squared, 3 minus a -1 is +4 squared, and I get 4 plus 16, which is square root of 20, which simplifies as 2√5. So now I know the lengths of all 3 sides of this triangle, and all I have left to do is add them together. Now keep in mind, if you're asked for your answer in exact form, which means you simplify your radicals and you leave them alone after that, then adding them all together means some you can maybe simplify and some you can't. But if you can't simplify, you just leave it. So let's see, 6 plus, there we go. Now, how do I know if I can simplify these? If you have radical expressions, the only way you can add them together is if exactly the same number is underneath the radical. And it's not. So I can't do anything here. So this would be the exact answer. You can't combine integers with radical expressions. You can't. Those are not like terms. Adding and subtracting is always about combining like terms. None of these are like terms. Okay? If I had had this, then sure, I'd have like terms and I could combine these and do at least partial combination. I don't have that. If I had had this, I could say, oh, 4 of something plus 2 of something. Same thing. This is kind of like if I had 4 of x plus 2 of x. So that would be 6 of that thing. But I don't have that. I've got all different types of terms. So that's the final answer for exact form. Now I could put it in my calculator and get a decimal approximation. All depends on what you're being asked for on your worksheet, homework, assignment, what have you. And I get about 16.13. That's approximately 16.13 for the perimeter. Okay, so on these next 3, 2, 3, and 4, all three of them are quadrilaterals. And I need to figure out what kind of quadrilateral. we talked about how you find the parallelogram area one way, rectangle area a different way, square area another way. So I need to know what kind of quadrilateral do I have. So here's what I'm going to do to find that out. I'm going to look at the slopes of the sides. And let's start out by labeling my vertices. QRST is what I'm going to go with on this one. It looks to me like that's a square, but I need to find that out. I need to know. So I'm going to find the slope of each side. All right, slope is rise over run. You can do it two ways. You can do it visually, or you can do it with the slope formula. Let's do QR with the slope formula. Okay, so if I want, and there's not a symbol for a slope, so I'm just going to say slope of QR. Excuse me. Q is at -3, 1. R is at 1, 3. I'm fond of those points, apparently. I've reused them here. The slope, remember, is the difference between the y's. So I can subtract my y's, 1 minus 3, over the difference between the x's, -3 minus 1. Now, sometimes I'll have students say to me, you didn't do the points in the right order. You didn't do 0.2 minus 0.1. Well, who's to say which is 0.2 and which is 0.1? That's completely up to you. So it really doesn't matter what order you do it in, as long as you're consistent. For my y's, I did the top point minus the bottom point. So I had to do the exact same order for my x's. I can't do it one way for the y's and the other way for the x's. So this gives me -2 over -4, which is about, not about, it's exactly 1/2. What if we'd gone the other way? What if I had been a real big fan of the formula and said I'm going to do it exactly what it says. I'm going to do 2 minus 1 on top. That's 3 minus 1, or y sub 2 minus y sub 1. And on the bottom, I'm going to do x sub 2 minus x sub 1. And I had labeled my points this way. 2 over 4. You'll get the same thing. Both signs will be different, but that will simplify to be the same because a negative over a negative is a positive. So either way, we get 1/2. Now, one thing to keep in mind anytime you're being asked about slope or needing to find slope, remember that slopes that are positive rise from left to right, and slopes that are negative fall from left to right. Why is that important? Because it's really easy to mess up the signs. So you want to make sure that the answer you get makes sense in terms of, is it positive or negative? This is going up from left to right, so it should be positive, so I must have done the right thing with my signs. When I look at RS, I'm expecting to get a negative slope because it is falling, going down from left to right. All right, so let's look at RS a different way. We already have our slope for QR. And I'm just going to write it on here. Slope is 1/2. Now, RS, I'm going to do it visually. I'm going to say, how do I get from this point to this point? I could have started with S. It doesn't matter which point I start with. To get from R to S, I go down 1, 2, 3, 4. Down, up and down are a Y thing. Remember what I said here. Excuse me, the top number on your fraction for slope is whether you're going up or down. Down is negative, so I went -4. So for my slope of RS, on top I have -4 so far. And then from there I'm going to go to the right 1, 2. Right is positive. So the bottom number is going to be a +2. And this simplifies as -2. You would get the same thing if you started at R and went right first and then down, as long as you remembered to put the right first in the denominator. The left and right goes in the denominator, the up and down goes on top. If you had started at S and gone this way or gone this way, as long as you remember it's the up and down that goes on top, and up is positive, down is negative, and the left and right goes on the bottom, and left is negative, right is positive. All right, here we go. This is slope of -2. Now I'm going to go ahead and find the slope of TS. That's up 2, and 1, 2, 3, 4 to the right. So for TS, I get up 2, 4 to the right. That's 1/2. So the slope of TS is 1/2. 1/2. And then for QT, I go down 1, 2, 3, 4, and right 2, which is exactly what I did here. So for QT, it's -2, just like RS. I do the exact same thing. You can even see it if I trace it. Down 4, right 2. So there are my slopes. So I know two things from these slopes. One is I know that opposite sides have the same slope. So it is a parallelogram, so that's great. The other thing I know is that any two sides that are next to each other, like this one and this one, have opposite reciprocal slopes. If I take 1/2, flip it over and change the sign, I have -2. That means they're perpendicular segments. In other words, that means that this is a right angle. And the same thing happens here. So this is a right angle. Same thing happens with these two. So this is a right angle. And the same thing happens with these two. So this is a right angle. So I know that I have a rectangle. I don't know yet that I have a square. In order to find that, I would really probably have to find the lengths of the sides. Now, that's not the only way to find that out, and this is not the only way to find out any of this, but since I'm trying to find the area and perimeter, I'm going to need the lengths of the sides anyway. So let's go ahead and find some side lengths. I'm going to find the length of, let's start with QT. And we're going to do distance formula each time. Well, first of all, let's mention all the points. Q is at -3, 1. R is at 1, 3. S is at 3, -1. And T is at -1, -3. If you don't identify the points correctly, that is going to put you in the wrong place to begin with. So make sure you always are very careful about identifying your coordinates of the points. All right, distance formula, and I'm going to do it 4 times. So I'm going to go through this kind of quickly. You are welcome to pause at any time. So the length of QR, I'm doing the difference between my x's, difference between my y's. That gives me square root of 20, which is 2√5. All right, next up, RS. 1 minus 3. 3 minus a -1. Oh, sorry, that's +3. Let's do that. Two squared, 4 squared, same numbers. What do you know? I don't need to go through this process over and over again in terms of simplifying if I know that it's always going to be the same numbers. Let's see. ST guess what? Same numbers. And TQ, how much you want to bet, right? -1 minus a -3. That's going to be 2. And -3 minus 1, which is going to be -4. Same numbers. It's a square. All these sides are the same. So I'm ready to find my area and perimeter. Okay? It's a square. When you have a square's perimeter, sorry, I'm having trouble speaking. It's a basic thing. Perimeter of the square means add up all the sides. So I've got 2√5 4 times. These are like terms. Remember that talk we just had about combining like terms? Those are like radicals, and so they're like terms. This is like 2 times something plus 2 more of the same thing plus 2 more of the same thing. It's a lot like if it said 2x plus 2x plus 2x plus 2x. I have 8 of that thing. I have 8 √5s. There's my perimeter. The area is going to be length times width. The length and the width are the same, so another way to say this is side squared. Be careful squaring this. A lot of times people type this in the calculator incorrectly. It's probably safer to think about it like this. Remember that when you're multiplying, order doesn't matter. You can rearrange things all you want. So you can put the 2's next to each other and the radicals next to each other and say 2 times 2 is 4. Square root of 5 times square root of 5 is just 5. So that's 20. Okay? If I type it in the calculator, let me show you what happens. A lot of times students type in this. That's not 20, is it? Well, that's also not doing what I'm supposed to be doing here. This is asking my calculator to do this. That's what that did. It only squared the radical 5, the square root of 5. Okay? If I want to square the whole thing, I have to put the whole thing in parentheses. Okay, so that means we have the area of our square and the perimeter of our square, so we are done with that problem. And since we are already 26 minutes in, I'm going to go ahead and call it for this video, and I'm going to do these other 3 figures in a separate video that you can watch or not watch, your choice. Thanks for watching this one, and I'll see you next time.